Today we're going to talk about mutually exclusive events. This will wrap up our conversation about probability, and it also wraps up all of our new material. So it's kind of an exciting day. So non-mutually exclusive events are events that share one or more of the same outcomes. So we saw that just briefly on the last question on your homework about sophomores and girls. So let's jump in and do a little bit of a couple of examples here. So we have one dice that we are going to roll. We have the event of rolling an even. So what is our set of even numbers on a die? Yep, 2, 4, and 6. And then we have the event of rolling a multiple of 3. What are the multiples of 3 on a die?
6 and 9.
Yeah. Okay. Real quick before we even get started with the questions, do we have any overlap there?
Yes.
Do we have any sharing? Okay. So that tells us that we are non-mutually exclusive because we have some sharing going on. Two things that can happen at the same time. That 6, if it shows up, fits both categories. So what's the probability that we're going to roll an even number? 3 out of 6. Good. What's the probability that we're going to roll a multiple of 3? 2 out of 6. What's the probability that we're going to roll an even or roll a multiple of 3? And we talked about ors last week, meaning that we add. Okay, so 5 out of 6. But what happens when we have an even or a multiple of 3? We have that 1, that's 6, that's the double dipper. Okay? That 6 is our repeater. So really our answer is 4 out of 6. Because you can't count that 6 2 times. So, letter E. Why is 4 out of 6 not really the sum? What happened there?
Because you have an overlap.
Yep. Well said. We have an overlap. I call them double dippers, but that's exactly the same thing.
We use these weird words like that. Like getting marks pointed out or pointing out for a second.
No. If you had said, for example, if that was a question on the regions, if you say we have a double dipper, I will fight very hard that you get credit for that. Okay? Because that's the term that I use. And I believe, especially this first year, everybody's going to be very generous in their grading because we all talk differently. So I do like this box, and you know that oftentimes I don't. This time, if we have a non-mutually exclusive event, okay, so we have the double dippers or overlaps, we're going to add them together because we still have the or situation, but we have to subtract that double dip or overlap. All right, let's do a few more. If one card is drawn at random from a standard deck of cards, what is the probability of a randomly selecting a 10 or a red? Okay, so what's the probability that I'm going to get a 10? 4 out of 52. Good. What's the probability that I'm going to get a red? 26 out of 52. Do we have any 10s that are also reds?
Yes.
Yes. How many?
2.
Good. We have 2 that are overlapped or double dippered.
That'd be 28.
So we have 28 out of 52 chance.
Do we have to reduce it all?
You do not have to reduce. You're welcome to, and if you do this on your calculator, it will, but you do not have to. Number 3, a fair 6-sided die is rolled. What's the probability of rolling an odd or a number less than 3?
It's 3 odds.
Okay, so Odd number, correct, 1, 3, or 5. So that's 3 out of 6. Number less than 4, 1, 2, or 3. So another 3 out of 6. Do we have any overlap?
Mm-hmm. 1 and 1.
So we have 2 numbers. Whoops, I didn't want to make that an equal sign. We have 2 numbers that are an overlap.
Wow. Be passionate about something.
What do we get for a final answer?
4 and 6.
4 out of 6. Okay, to the back.
Word problems.
We just did word problems.
But they're not big facts.
Oh, they're just a little bigger. They're not scarier. On a given night in March, the probability that it's going to rain is 60%. The chance that it's going to rain and snow is 17%. And the chance that it's just going to snow is 32%. What's the probability that it will rain or snow? Do we have overlap included in our problem? Yes, yes. Right here is the overlap. The word "and" is your clue that you have some overlap. Okay, so probability that it will rain, they tell us, is 60%. The probability that it will snow is 32%. And what's the probability that it will rain and snow? That's 17%. Okay, so we have the overlap, it's just a little hidden. And I got 75. Anyone else? Okay. That seems about right for March, doesn't it?
Yeah.
Actually, a little sad it's kind of right for May this year, too, I think. Okay, number 5. The probability that the Fritzy rugby team will win is 68%. Probability that somebody's going to get hurt is 36. Probability that the team member gets hurt or they win is 86. We're supposed to find the probability that the team wins and someone gets hurt. This time we have to find the overlap. So let's go back up and talk about our, or we can go to the front even and talk about our equation. This, I've been trying to do them in different colors. So this is the probability of the first event. This is the probability of the second event. Then we minus the probability of the overlap. And that's going to equal, hold on, overlap is the word "and," is our clue. That's going to equal the probability of A or B. Okay? And that's what our formula says on the front. So, let's jump in here and have a great time. What's the probability that we're going to win? 0.68. What's the probability that someone's going to get hurt? Do we know the overlap? We don't know the overlap. But we do know the final outcome, the OR situation, is our 86. Questions on that one? Yeah. All right. Somebody? Anybody?
How do we find X? Like, do you leave it in percent form or do
You leave it in decimal form and then convert it to a percent, yeah?
But does it have to end in a percent?
Yes.
Okay.
Yep, because everything else was given as a percent. So that's the reason that you would adjust that. So we just do our math. Remember, that's a negative X there. Be careful. Pay attention. Did you get an 18?
Yes.
So an 18% chance that they win and someone gets hurt. As a mom, I like that percent. Only 18.
Could be worse.
It could be. Sometimes I feel like it's worse. Number 6. Shane would like to take her son Maxwell to the zoo, but they're only going to go if it doesn't rain. Well, it better not go today. Probability rain is 20%, probability rain is 40%. Assume that they are independent of each other. So, what's the probability that it won't rain on Saturday? 80%. What's the probability that it won't rain on Sunday? 60%. What is the probability that it won't rain on Saturday and it won't rain on Sunday? Remember when we did independent events before, when we had an and, we multiplied. And that and is going to become our overlap. Okay? Or double dipping. So what's the probability that it won't rain on Saturday or Sunday? Here is your clue that you need to use our little formula from the front. Okay, so won't rain. 0.8, I don't need parentheses, I'm sorry. Minus our overlap gives you the chance that they're going to go to the zoo, which I think I've calculated to be a 92% chance.
That's what I have.
Perfect.
Oh, sorry, I did not.
Okay, so be watchful, especially those word problems, for that overlap.